Let's solve the following linear inequality. So here we have the inequation given by 2x plus 4 divided by x minus 1. We'll transpose the 5 from the right hand side to the left hand side. So we have negative 5. So this is less than or equals to 0. Let's combine the two terms on the left hand side. We'll have x minus 1. In the numerator we have 2x plus 4 minus 5 multiplied to x minus 1 will give us negative 5x plus 5, which is greater than 0, greater than or equals to 0. So we have negative 3x plus 9 divided by x minus 1. So this is greater than or equals to 0. What we have to do is we want to make the coefficient of x in the numerator positive. That means we need to get rid of this negative 3 here. For that we are going to divide each side with negative 3. Now, before doing that, we have to use the fact that if we have a number a which is greater than or equals to b, and also another number c which is negative, then in that case, if we divide a by c and b by c, in that case, the sign of the inequality changes. So we have to use this fact here. Now, since we are going to divide by negative 3, so we will have x minus 3 divided by x minus 1. So this will become less than or equals to 0. But divided with negative 3 on both sides. Now, to solve this, this is our linear inequality that we need to solve here. For that, we are going to obtain some critical values. So, critical values are defined as those values where the numerator goes to 0 for those particular values of x, as the numerator as well as the denominator goes to 0. So, if x equals to 3 and x equals to positive 1. Now we'll consider a number line, and on it we are going to plot the value x equals to 1 and x equals to 3. Now we'll consider some values. Let x be 0. So x 0 means it's a value which is lying to the left of x equals to 1, or we can say values lesser than x equals to 1, and we will substitute that value into our rational expression, which is x minus 3 over x minus 1. This should give us, we will have 0 minus 3 divided by 0 minus 1, which is negative 3 over negative 1, that's 3. We are getting a positive value. So here, we are getting a positive value. Then we are going to consider the value between 1 and 3. So we'll consider x equals to 2 and substitute into our rational expression. So we have 2 minus 3 divided by 2 minus 1. So that gives us negative 1 over 1, which is a negative number. So here we have a negative value. And we'll consider another value, x equals to 4, which is greater than x equals to 3. And when we substitute into a rational expression, we have 4 minus 3 divided by 4 minus 1. This gives us 1 over 3, which is a positive value. So here we have a positive value. Now, we want to find a solution to a linear inequality, which says that we can only consider the value which is less than or equals to 0. That means x minus 3 over x minus 1 must be negative, and this is the only region where it is negative, elsewhere it is positive. So this is a region of solution, or the region where values of x will lead to this expression be less than or equals to 0. So we have x greater than 1 but less than 3. Now the next question is our 1 included? Is 1 a part of the solution? That's not possible, because if we take x equals to 1, then this particular rational expression is divided by 0, which is not allowed. So we'll say it can only take value greater than 1. 1 is not included. But what about x equals to 3? That's fine. If we consider x to be equals to 3, this becomes 0, and we have 0. So if we put x equals to 3, we have 3 minus 3 divided by 3 minus 1, which is 0, and 0 is also less than or equals to 0. At least it's equal. So that's fine. So that means x will be less than or equals to 3. So this is a solution to our linear inequality. And if we want to show it graphically, so we'll put a hole at the place of x equals to 1, and we'll consider all the values between 1 and 3, and 3 is included. So we'll put a dot here. And in interval form, the solution will be values between 1 and 3. 1 is not included, but 3 is included.